Okay, so we're going to skip a section, and the last section we're going to do before break is starting off with differential equations in 7.3.1. The first differential equation we're going to see is just an equation with a differential in it, which means it has a derivative in it. So how are we going to solve for y? So let's go ahead and start off with our original equation. And our goal is to solve for y. So let's move the dx onto the other side. Now, this is convenient here because we can take the integral of both sides. The integral of dy says the derivative of y, so we're just going to say that this is y, or the it's the derivative of 1, right? So 1 is y because the derivative of y becomes 1. So we're going to say this is y plus c, and the antiderivative of x is going to be x squared times a half plus c. There is a c on both sides, but they're not necessarily the same c, so if I subtract a c on both sides, we are still going to have a c at the end, because the c could represent any number. Now, what this means is that if I was to take the derivative of this equation, regardless of what we have for c, we will end up getting the same equation as above. Let's go ahead and try it. The derivative of x squared is going to go down in front, so this is going to cancel out. So we are just going to be left with x. And the derivative of y is dy dx. So that's how we're going to solve equations like this. We're going to do 3 more. So let's do a here. It already tells us dy dx. So let's go ahead and start. Let's multiply both sides by dx. Our goal is to solve for y. So now we have a dy on one side, we have a dx on the other side. Let's go ahead and integrate both sides. The antiderivative of dy, or 1 dy, is just going to be y. So we'll say this is y plus c. The antiderivative of cosine of x is going to be sine, because sine turns into cosine, but it's going to be 6 sine plus c. We're going to subtract a c on both sides, and we have 6 sine x plus c. Testing out, if I was to take the derivative of 6 sine x, we would get 6 cosine x. Let's go ahead and do b here. We have dy dx equals x cubed. We'll multiply dx onto the other side. We'll take the antiderivative. This is just going to be y plus c. This is going to be x to the 4th, but we're going to have a 4th in front of it, plus c. So therefore y equals 1/4 x to the 4th plus c. Now, c is a little bit weird. So let's go ahead and write that one down. We have c dy dx equals y. Now, we're going to do the same process, and we're going to see something a little bit strange here. So notice in the other ones it said dy dx equals something x. Like, we have y already. So aren't we already done? We already solved for y. So why aren't we done? Well, because we have a differential in there. So we got to get rid of that. So we have dy equals y. Well, I'm going to switch these two. So we have over y dx. And we're going to see why that's the case in a second. So I'm going to rewrite this as 1 over y dy equals dx. Now I'm going to take the antiderivative of this. So the antiderivative of 1 over y dy equals the antiderivative of dx. Well, I'll just write 1 dx. So what is the antiderivative of 1 over y? Well, that's going to be ln y plus c. And the antiderivative of 1 with respect to x is going to be x plus c. Ln y equals x plus c. We want to solve for y. That was the whole point of us doing this. So I'm going to write this as log e to the y equals x plus c using our change of our log properties. We'll say this is y equals e to the x plus c. Now, your book isn't going to have this as an answer. Your book is going to have want us to separate these two, so or do something with this c. So we can write e to the x as e to the x times e to the c. So since they both have the same base of e, oh, my cat jumped on my lap. So e to the c is just a number. It's a coefficient. So we could just say this is e to the x with a c out in front equals y. Okay, so that is going to be your assignment. I will see you on Friday.